Hello everyone, myself Nandan, fifth semester AML department, GM University, and these are my team members Nikhil, Kushal, and Chinmay. And our we are going with our assignment one of the course name Deep Learning and Large Language Model, uh, initiated by guided by Miss Chaitra ma'am, Assistant Professor AML department, GM University, Davangere. Here we have the problem statement of that two deep learning optimization method like Adam versus RMSProp and analyze their effect on CNN training for CIFAR 10 for 10 dataset. Uh, Coming to the next slide, we have here our team members. Team members are Kushal, Chinmay, and Nikhil. And we are going with to the introduction part for our problem statement. Conventional neural networks (CNNs) are termed as conventional neural networks are widely used for image classification tasks. CNN are widely used for image classification tasks and for an optimizer play a crucial role in CNN training affecting converge speed and accuracy. This use for effect in converge speed and accuracy and these objectives like comparing the effect of Adam and RMSProp optimizers on CNN training performance using CIFF for 10 dataset. In the next slide, we have here objectives. What are the objectives we used here to evaluate the effect of different optimization algorithm on CNN training performance? We use a different algorithm or optimization to compare Adam and RMSProp optimizers on the CIFAR for 10 datasets to analyze training and validation accuracy, loss, and the convergence speed for both optimizers. We use the loss and accuracy for the both optimizers to identify which optimizer is more efficient and suitable for image classification tasks like CNNs. We used which one is the best. In the next slide, we have CIFR for 10 dataset. We used here 60,000 color images of size of 32 into 32 pixels and 10 classes airplanes, automobiles, birds, cat, deer, dog, frog, horse, sheep, and truck. And for the train or a split data 50,000 and bar 10,000. Pre-processing steps like normalize pixel values and convert labels to categorical one hot ending. And the next slide will be continued or explained by my friend Nikhil.
Coming to CNN architectures, in that input 32 into 32 into 3 images, convolution layer plus value plus max pooling, fully connected layer, output layer 10 neurons, max activations, optimizers to test Adam and RMS Pro, visual CNS block diagrams. These are the architectures. And next slide is about Adam optimizers. In that, Adaptive Movement Estimation (ADM) combines momentum and RMS pros. Learning rate 0.001, it is a default, and dash size 64, and epoch 5. Result training accuracy 84%, validation accuracy 80%, training loss curve decreasing trends, visualization line graph of a loss and accuracy over epochs. Next slide. RMS Pro optimization. Root mean square propagations, RMS Pro. Adapts learning rate based on recent gradient. Learning rate 0.001 defaults. Base size 64. Epoch 50. Result training accuracy 92% and validate accuracy 84%. Training loss curve decreasing trends. Visualization line graph of a loss and accuracy over epochs. And next slide is continued by Chinmay.
Hi everyone, here is the comparison of optimizers. In metric, we used training accuracy. In Adam, it has 95%. In RMS Prop, it has 92%. In next validation accuracy, in Adam, it has 94% percentage, and in RMS Prop, it has 93%. And the training time in Adam, it has 9 seconds per epoch, and in RMS Prop, it has 10 seconds per epoch. In lastly convergence speed in Adam it is faster, and in RMS Prop it is slower and similar. In next slide, it key observation. Adam achieves higher valuation accuracy in favor approach, and prop is effectively, but many require more fine tuning of learning rate, and the choice of optimizers impacts both speed and final performance of CNN. And lastly, it suggests combining technicals like learning rate scheduling for further improvements. And here lastly conclusion, optimizer selection significantly affects CNN training outcomes. For CIFAR 10, Adam is faster and more accurate for this architecture. RMS Prop is stable but slightly slower. And final recommendation, Adam preferred for general purpose CNN training unless specific stability requirements exist. And next code part will be explained by my friend Kushal.
Thank you, Chinmay. Now I am going to explaining the code part. We are taken a code part is Adam versus RMSC Pro. Adam is adaptive momentum, and the RMSC is root mean square propagation. In the first, we had to implement ER. We have taken a CNN optimization comparison of a Adam versus RMS propagation. Here we taken a data set as CIFAR 10 data sets. Here we import some libraries like TensorFlow and importing datasets, layers, models, and matplotlib is for graph visualization. We used matplotlib library. And first step, we load the pre-processing the dataset of a CIFAR, and here we initialize a x and y variable and define the CNN model. Here we build a CNN model. We have taken a model is a conventional 2D, and it is a 32 into 32 pixel of input size, and we are taking layer as a max pool, and the max pool is 2D and layers pattern, and return the model. Next, train with the different optimizers. We have taken only a 5 epochs because the epochs are more. We have taken the data set is 60,000. In that 60,000, we have taken 50,000 as a training data set and 10,000 as a test data set. So it is so lengthy process. Here we have taken 5 epochs and the batch size is 64. Adam optimizer is built a CNN model and print the training with Adopt optimizer and RMSProp optimizers, and it is also build a model and print the model optimizer with SGD and evaluate all models. He'll evaluate all models Adam versus RMSOP prop and plot to validation loss comparison. Here we have taken the learning rate as 0.001%. 1 as taken the, and here plot validation loss comparison is figure size is 8,5 and show up, and we have taken the 10 classes of data sets like aeroplane, frog, something we are taken as 10 classes and compare the validation of the loss, and it estimates the loss of comparing loss and the accuracy, and it shows the plot of the graph. Show the graph, Chinmay, once you. And this is the validation loss of the epochs. It has a 5 epochs we have taken, and 5 is per one is a Adam optimizer and the RMSOP prop and SGD momentum. This is the loss function. In blue line, it shows the loss of the Adam optimizers, and the orange is RMS prop, and the green is SGD momentum. Validation accuracy comparison of RMSOP and Adam optimizer. This is the results. Thank you, Chinmay.
Thank you, everyone.
Thank you, everyone.